Today we are going to discuss a problem called maximum sum subarray problem. So what is a maximum sum subarray problem? Given an array, you have to choose a subarray whose sum is maximum. Now we are assuming that the subarray is a non-zero subarray. That is, the size of subarray could be either 1 element, 2 elements, and so on until the size of the array. A naive would say that we check over every point and see all possible subarrays, and then we can compute the maximum out of it. But that would take O of n square complexity, which is definitely not good. We can solve the same problem in O(n) time complexity by using Kadane's algorithm. Kadane's algorithm basically works on the fact that you compute until the point the maximum value, and for every point you could either take it or you can take it not. So here's the code. Suppose we have taken an integer max so far, which would give the desired result, and the current max is going to return us the value, the current up to current value, up to current index, the maximum value up to current index. So for the first iteration we would see that -1. Current max would be -1, and max so far, since it is initialized to int min, which is the minimum value of integer, so obviously at this point current max will be greater than max so far, so max so far equals to -1. Proceeding into next, since at this point current max is less than 0, we have to initialize it to 0. Why? Because adding a negative number to any number will obviously make it smaller. So at every point, after every iteration, when current max is less than 0, we are going to again initialize this to 0. So again current max is initialized to 0. Now at next point, current max would be -2, which is less than max so far, so max so far remains -1. And again it is initialized to 0. Next point, it will be 3. 3 is greater than max so far, which is -1, so this is updated to 3. So now our maximum sum subarray is this element, and in next point we will add 4 to it, plus 4, that is equals to 7, and our max so far will also be updated to 7. Since it is greater than 0, this will not work here. In the next iteration we would add -5 to it. Adding -5 will result in 2. Since 2 is greater than 0, this will again not be executed. But a max so far is greater than 2, so it remains 7. Because at this point we can say that subarray sum is the sum of these two elements without including this one. Okay. So now coming back to the final point, when we add 6 to it, we get the answer 8. And since 8 is greater than 7, our max so far is updated to 8. And at this point the loop terminates and we return max so far, which is equals to 8. So in this, we saw that the algorithm takes O of n time because we had to iterate the whole array only once, which is equals to n, that is the size of the array. So this is a very efficient method to solve various competitive problems. Thank you.